So when trying to pick the right value for the gas constant to use in any particular problem, we always say you need to look at the units of pressure and the units of volume that you have. But there are values for the gas constant that don't have any pressure or volume in them, but instead have units of energy. And that's because pressure times volume is a quantity that's actually equivalent to energy. And for a lot of problems where we're trying to relate motions of gases to their kinetic energy, it's important to use the gas constant that has energy units. And so if we think about what the units are, we have pressure times volume, which is an energy, divided by a numbers of moles. So that gives us an intensive energy that's the energy per mole relative to what the temperature is. And so what we discover is that the value for R is actually a very important universal constant that relates how much energy a substance has to the temperature. And in particular, it relates its average kinetic energy to the temperature. And so when we start to do problems where we're thinking about changes in energy or the energy that a compound has and the ideal gas constant comes up, we don't want to be thinking about liter bars, we don't want to be thinking about liter atmospheres, but we want to think about common energy units, typically joules, 8.314 joules per Kelvin per mole. There are some people who continue to think about calories. We'll try to forget that and always stick with joules. Alternatively, we can dream up horsepower hours per mole per temperature, but thankfully joules is one of the units that we can settle on, and so almost every single problem that relates energy to temperature is going to have the gas constant in joules.